Here we see the moment the electron has expanded with its radius increasing from 91 in short nanometer to 364 nanometer. This means that any point on the electron has covered a distance of 273 nanometer at speed of light in each direction. 2. While electron expands between 91 nanometer and 364 nanometer at speed of light in the continuum, for each moment its point mass and point energy decreases as the wavelength increases, while its tangential speed and angular momentum, in other words Planck's constant, remain unchanged. Tangential speed 6.28 times greater than the speed of light. Arıdaşır's principal constant and formula: the product of point mass and point wavelength is constant for atomic electrons. 3. How long does it take a point to travel? 273 nanometer. 4. Here, I hope you see 4. Time equals 273 nanometer divided by speed of light. 911 point attoseconds. This is our time interval. From now on, we can certainly determine position and momentum of any point simultaneously for each instantaneous moment. Okay. 5. Assuming the effective wave encounters a hygienic electron at time is equals to 0, how much distance does the point on the 91 nanometer initial wavelength size hygienic electron cover within 100 attosecond instantaneous moment when it reaches the destination? 6. A point on a ground state hygienic electron surface with an initial radius of 91.155 nanometer moves. Delta lambda is equals to C multiplied by 100 10 to the minus 18 second, 100 attosecond, equals delta lambda 30 nanometer over 100 attoseconds at the speed of light. At that moment, the radius wavelength reaches 91 nanometer plus 30 nanometer equals 121.155 nanometer, based on which the mass at a point on this radius will be calculated. Okay. 7. What is the point mass, electrophoton mass or photon mass? Formula of METİN Arıdaşır. What is point mass at the 100 attosecond? Here it is. Arıdaşır's point mass formula. Angular momentum is Planck's constant according to me, and this is the mass. Where it is? 1.823 10 to the minus 35 kilogram. This is point mass at the 100 attosecond. Eventually, this is point mass at the 100 attosecond on the lambda instantaneous equals to 121.155 nanometer position point. Position. Yes, here it is. 8. Now I will compute momentum of a point on 121 nanometer position. Momentum equals m multiplied by speed of light equals to 5.469 10 to the minus 27 kilogram meter per second, while it is the position wavelength of an effective traveling the distance wavelength between 91 nanometer and 364 nanometer at speed of light at the 100 attosecond as an instantaneous moment, the position of an effective point on expanding electron surface is lambda instantaneous position is 121 nanometer and momentum is 5.469 10 to the minus 27 kilogram meter per second. 9. Arıdaşır's certainty equation. Eventually, here it is, eventually, position and momentum of every point on electron can be determined certainly and simultaneously, and the product of position and momentum is always constant and invariable, is always angular momentum of electrophoton, in other words, Planck's constant. This is certainty equation here. Then multiplied by, according to formula, result Planck's constant, angular momentum, unchanged, invariable, constant. Okay, here, so Arıdaşır certainty formula versus uncertainty formula of Heisenberg. Okay, have a good night, see you later, METİN, Arıdaşır.